Welcome to AP Stat, Chapter 21. If you are hearing this, that means I am homesick. Unfortunately. Anyway, we're going to go ahead and I'm going to give you the notes about Chapter 21. We're going to take a little bit, we're going to take the p-value, we're going to take our hypotheses, and we are going to try to take it to the next level in terms of understanding what we're looking at. So, you should have received an email. If you haven't checked, make sure that you check. I'm going to have sent this PowerPoint slide on each page. You should have gotten a copy of this. So, if you have it and you've already printed it out, fantastic. If not, then take notes, but realize that you do have these to print off at home. So no worries if you want to write down the things that kind of I annotate on the side or things that are important. But here we go. We've introduced a confidence interval in Chapter 19. In Chapter 20 we talked about significance tests. And this is just kind of taking that test to the next level. We're going to talk about really what's important. What do we do at this in the last chapter? It was kind of arbitrary. You didn't reject or fail to reject, although we talked about that, but did you have evidence? Was it strong, weak, moderate? What kind of thing? That was almost left up to you to interpret yourself. In a real life scenario, we would have to have a standard. We got to have something that says this is enough evidence and this is not. And so part of what we're going to do is we're going to look at the p-value and talk about what we call an alpha level and decide on what's appropriate, what's not. The example we're going to look at is called a therapeutic touch. So this situation, this is in your book on page 484. If you want to turn to the book, it might help you follow along a little better. So while I'm explaining the story, you can turn in your books. Therapeutic touch, it was believed, or it was curious, they were curious on if people had extrasensory perception. Some people claim that they did, and I believe your book says an 8-year-old girl decided that she was going to test it out. And she came up with this pretty cool test, and basically she allowed the person that claimed to have these abilities to try to feel her aura, her presence, when she put one hand above their hand. At first they did this just straightforward. She put her hand above it and they tried to get a feel for her presence, whatever you want to call it. And then once they kind of got a baseline test, then or a feel for it so they could see their aura, then they put up a blindfold, a big cardboard box or whatever, and underneath the box, the person that had the ability would stick their hands underneath, and the person on the other side would put their hand above one of the hands. And basically they recorded, they did this a number of times. Of course they could get it right or wrong. There was a 50-50 chance, and that's kind of where we're going to start from here. So, therapeutic touch, it was, they had 15 practitioners who did it 10 times each. So we had a fairly large trial. And our HO, because we're claiming that they don't, well, the absence of the effect present, right? The effect that they're looking at is, do they have this therapeutic touch? So if they are lying and they don't have it, which that's kind of the hypothesis here, that we're going to assume that they could get 50% right. So if they did it 10 times, then we would expect them on average to get it right 5 out of the 10 trials, just by guessing. Because, I mean, theoretically it's like flipping a coin. You have 2 guesses, half the time it's going to come out on heads, half the times it's going to come out on tails. And that's in fact how they decided which hand to put it over. They allowed a coin to choose rather than using their own opinions to choose. That would have been a little bit biased. And so they did the coin trick. So we go in alternative. Now we're trying to show that they actually have this ability. And so if their percentage falls above 50%, this is a lot like the home field advantage question. And so if their percentage falls above 50%, then we believe that, well, they're doing better than guessing. But the question that we need to answer is, what's that cutoff mark? How much better than 50% would they need to do to show that they're doing better than just the average person? If you go through our assumptions and conditions, you'll find out that they're all satisfied. Random sampling. Here again, this isn't technically random, but there's no reason to believe that they would be biased. These 15 practitioners most likely represent the entire population of practitioners because they're full of crap. Just kidding. Independence. One person's ability is, they're separated, so they're not sitting next to each other. When one person guesses, they're not listening. Independence is held. 10%. I assume that there's more than 150 practitioners in at one time. I think that's a safe assumption. Success or failure. We had 0.5 times 15. No, not 15. I guess the sample size is really more like 150. Because we did it 150 times. So each person did it 10 times. And so you have 150 trials times 0.5. And so we're good on that. We had a p-value in this problem of 0.467. Okay? Or no, I'm sorry. This is the observed proportion, which is a little awkward because they didn't even get 50% right. You could put a dog out there and he could go to one side or the other and should get about 50% right. So what we wanted to do in this problem was to find the p-value and basically interpret what the p-value means. But before we get there, let's talk about p-value. P-value, as I said earlier, is a conditional probability. It's the probability of the observed statistic, and that's your z-score, given that the null hypothesis is actually true. And if you were to write that down in, in mathematical phrase, you got this situation here. P of observed statistic value, given that it's HO. Now, what I need to be able to do is I need to interpret this. I need to know exactly what it is. I need to know when I write my conclusion, and here's the bottom line. When I write the conclusion, I need to be able to know that when I say about my p-value, that I am comfortable with what that means. A lot of you kind of, sort of, are getting the idea of what a p-value is, and that's good. And so it's just going to take a little more practice. So let's keep going. Now, here's where we really want to get into alpha levels. Then alpha, and I'll show you a picture in just a minute. Alpha is nothing more than the level that your p-value needs to drop below for you to reject the null. So when the p-value is small, it's telling you it's the probability that your sample gave you a result like this, assuming that the null is a true statement. So if I had, the probability is 0.01, so I should observe a result 1 out of 100 times if my null hypothesis actually is true. And so we have a choice. We can say that my null is probably false, or I can say that my sample is just extremely rare. We took precautions to make sure that our sample was representative. We took precautions to make sure that our sample was good and it was unbiased, and I didn't have to worry about that. So it's more likely to say that our null is not what they claim it is. So in the last bullet says if our p-value falls below the point, that's the alpha level, we reject the null, and we call those results statistically significant. Now, there's two things, statistically significant and practically significant. You can have something that is very statistically significant and be not practically significant at all. So just because it says that doesn't mean it means a whole lot in reality. We'll get to that later. So alpha level is also called a significance level. We will use these two phrases kind of interchangeably. I'll go back and forth. I don't think one is more valuable than the other or used more than the other. But when we say that, if it's statistically significant, that means I rejected the null hypothesis because my evidence was strong enough to say that my sample shouldn't really have occurred like this if the null is true. What you don't want to say, this is absolutely important that you write this down. It's in your book. A lot of you are going to state that the p-value is the probability that the null hypothesis is true. And some of you have already said that, unfortunately. The null hypothesis, or the p-value, is absolutely nothing to do with if the null is true or not. Okay? Don't make that statement. Let's see. What I want you to do right now is I want you to, there are a couple books up front, so grab a book. If you've got your book, if you have it in your locker, you might want to go get it. I need you to read the chapter. I keep saying this, and it's vitally important that you do these things. If you have yet to read a chapter, then you have yet to listen to me. Read your chapter. I want you to work the odd problems in your book. I'm not going to give you a certain number. 1 through 19 is probably good. If you get to the point where it starts talking about type 1 or errors, type 2 error, type 1 error, you can stop. I don't want you to do those questions. So it should be about 10 questions. Some of them start off pretty easy. It's asking you to make a description of the p-value. It's asking you to interpret the alpha level. Is it statistically significant? A lot of them will be quick and easy questions if you have paid attention. Read the chapter. I want you, if you haven't watched the video on type 1 and type 2 errors, you need to go and watch that video, or pull it up right now and watch it. I don't know. You might not want to watch it right now. It'll confuse you. We are going to talk about that tomorrow. What I need you to do, I need you to go home, or at some point, I need you to watch that video. It does a run through of what they are. It does a good job of explaining it to you. You may not understand what it is, but you'll get a lot of the vocabulary and you'll get a lot of the visual aids kind of in your brain. What I need you to do is watch those, and when you come to class tomorrow, assuming I don't have the flu, I really hope that's not true, we'll go through that, and we'll try to make some sense of type 1 and type 2 errors. That's going to be the more difficult part of this unit, chapter 20 to 23 or 22. Type 1 and type 2 errors are the most complicated, so make sure that you put a little bit of effort and time into watching those, and taking notes on them if you need to. Probably not a bad idea. And definitely read your chapter 21. And you have plenty of time the rest of the period, so work on those problems, work with each other, kind of help out. If you get stuck, you can email me. Well, maybe you can't email me because you're not supposed to have out your electronic devices. You can email me at home, and let me know if you have questions once you get out of school. And I'll see you tomorrow, hopefully.